Okay, here is a list of the rules for basic derivatives that you might encounter in this course. Most of what you encounter will just be power functions and sums of power functions or polynomial functions. You'll also encounter some sines and cosines and maybe a couple of exponentials in at least the first semester, a little bit more in the second semester. So to illustrate, and these are all rules that I believe everybody coming out of a first-year calculus course with any kind of standards at all would certainly recognize and understand, even though I wouldn't necessarily expect everybody to be able to prove them. Ideally, of course, we would teach the course in such a way we could do that, but that's not realistic with students coming out of an SOL-driven curriculum. Okay. And we also have the product rule. Product of two functions derivative is the derivative of the first times the second plus the first times the derivative of the second. The quotient rule, the quotient of two functions derivative of the numerator times denominator minus the numerator times the derivative of the denominator divided by the square of the denominator. And the chain rule, which I write in this form, f of g of x prime is g prime of x plus f prime of g of x. Probably the most universally applicable way to express that rule. And there's, of course, the chain of functions, a version of this rule, and we'll talk about that when and if it becomes necessary. But usually we're only going to have a composite of one function with another, not multiple composites. And it's not going to be necessary to use the chain notation. Okay, so just to illustrate, for example, and I'm not going to write out the ddx, I'm going to use the prime notation. Let's take x to the negative 2 prime. What's that equal to? Well, it's nx to the n minus 1, where n is negative 2. That means it's going to be negative 2x to the negative 2 minus 1, which is negative 2x to the negative 3, which is negative 2 over x to the third. And of course, you have to know the laws of exponents, understand why x to the negative 3 is reciprocal of x to the third, and so forth. Another example, square root of x can be written as x to the 1/2. And applying the rule, then it's going to be 1/2 x to the 1 to the 1/2 minus 1, which is 1/2 x to the negative 1/2, which is 1 over 2 times the square root of x. X to the negative 1/2 is 1 over x to the 1/2. And x to the 1/2 is square root of x. And certainly you will have encountered these and calculated them a large number of times. Okay, what about the derivative of sine x equals cosine x, derivative of cosine x equals negative sine x? There's not much to say about those. Now, of course, we can also get the derivative of the tangent. Tangent's the sine divided by the cosine. We can apply the product rule, the quotient rule to get that. But that's all fairly straightforward, as are the derivatives e to the x and natural log of x. However, these functions all give us the opportunity to illustrate the chain rule, which is something that people tend to still have difficulty with when they come into this course. Not everybody does, of course, but many people do. So we have f of g of x prime, etc. Well, let's just apply that. Let's do the derivative of the sine of x squared. Okay, now the sine of x squared is f of g of x. Okay, so that's f of g of x, where f of x, and I actually prefer to use a dummy variable here. F of u equals the sine of u, and g of x equals x squared. Okay, well, then g prime of x is going to be the derivative of g of x and that's 2x, and f prime of u is the cosine of u. So right there's everything we need to put together to do this. So g prime of x is 2x, and then f prime of g of x is going to be the cosine of g of x. Okay, because f prime of g of x, well, we know f prime of u is cosine u, so f prime of g of x has to be the cosine of g of x. And that's 2x times the cosine of x squared, since g of x is x squared. Okay, there's one simple application of the chain rule. Let's do one with an exponential function. So let's take e to the cosine x prime. That's not a function you're likely to encounter in this course, but it's still worth looking at. So it's f of g of x. F of u is going to be e to the u. G of x is cosine x. So that f prime of u is e to the u. G prime of x is negative sine of x. So what do we get? Again, we get g prime of x, which is negative sine of x, times e to the g of x. Since f of u is e to the u, f of g of x is e to the g of x. So then we have negative sine x multiplied by e to the cosine of x. So two straightforward applications of the chain rule. There's much more, but in first year physics, you don't encounter all that many functions that are much more complicated than the ones we've done here. For the most part, you don't even need the chain rule very much. Let me do one more typical example of the chain rule, and this is one that will be very important. And this one is the derivative of the sine of omega t. Make sure I got that prime out there big enough that you can see it. Okay, well, this is pretty straightforward. Your f of u is going to be sine of u, just like it was up here. Your g of x was x squared up here. Here it's just omega t. And what's the derivative of your g of x function? Well, the derivative of omega t, and of course the derivative is implicitly with respect to the variable, and the variable here is going to be t. Didn't mention that before, but that's kind of important to point out. Okay, derivative with respect to t of the sine of omega t. Okay, well, it's going to be g prime of t times f prime of g of t. T is the variable, not x in this case. Your g prime of x, your g of x is the inner function, that's the omega t, and the derivative of that with respect to t is just omega. And then that's times the sine of g of x times, the cosine of g of x, f prime of g of x. So that's times the cosine of g of t in this case, not g of x. So that's omega times the cosine of omega t. Okay, if we did a second derivative of this, and you can think this one through, but you should. Then, well, that's going to be the derivative of this. Now omega is just regarded as a constant, so we're going to have to take the derivative of the cosine function. Well, that is very similar to what we get when we take the derivative of the sine function. We're going to get omega from this constant out here, and then we're going to get another omega from the chain rule because we've got to take the derivative of the omega t function. And then that's times the negative sine of omega t. How many parentheses do I need here? Okay. So that's negative omega squared sine of omega t. Now, you want to keep your calculus at the level where you can do any of this very quickly and very easily. You should also be able to find the derivative of the tangent using the quotient rule and the derivatives of the sine and the cosine and other basic derivatives. It doesn't take much to brush that up if you're a little rusty.